So now for a different kind of project. So in the past I've dabbled in flashlights a little bit. You know, I've upgraded some flashlights, even gone as far as designing some of my own circuit boards, making some of my own drivers. A little bit. I haven't got into it too much. Upgraded a couple of flashlights, but this has been my everyday carry flashlight for quite a few years, many years, at least 4 or 5 years. You can see it used to be black anodized aluminum, and it's now getting to the point where it's anodizing is all wearing off from being in my pocket. So this is a Sipik, S-I-P-I-K. I can't quite read it. The model, I believe it's a SK68. I guess back in the day this was a fairly desirable flashlight for a one-celled, what they call a zooming flashlight. So this is basically all stock, except I've put a lithium battery in it. It's originally made to run off a AA battery, but I put a lithium battery in here. It gives it a little higher output. I've got a protected cell lithium battery. That's a 14500 size battery, so gives it a little more output. But even though I like this flashlight quite a bit, I've carried it for quite a few years, it does have something to be desired. It's got a fairly cheap LED in it. It's very blue tint. The flashlight also comes on in high. It's got 3 modes: high, low, and then it's got a strobe mode for a everyday carry pocket flashlight. I carry this at work, looking inside machines and various things. I have no need for a strobe mode, and I'd rather it come on in low, and so I can, when I'm looking inside somewhere, come on in low and then have to cycle up to high instead of coming on high and being too bright and having to cycle down to low. So this is how the flashlight is originally. Doing high, low. It's got a flashing strobe effect. You see it's got some rings around it. You see the pattern of the LED when it's zoomed all the way in there. See, we got a little bit of ambient light in here, but see how it looks after we upgrade this. So there's various manufacturers that sell parts. You can upgrade these. I've opted to I'm going to update the LED. Here's the LED. I'm going to update this LED from its current brand to a Nichia, a 219C LED. About the 4000 Kelvin range for the color, but it'll be a 90 CRI, or color rendering index emitter, so it'll be a lot warmer tone. Won't be so blue, and it'll show colors a lot better. So for those who haven't seen inside a LED flashlight, there's your LED light emitting diode, and on the back, that's the back of the driver board. So the plan is to update this. So let's pull this out of here. So the board says it's a Cree LED, but I don't think it is. I think it's a replica knockoff LED. It's hard to see in here until I get this desoldered and apart. But this aluminum housing here, what people often refer to as the pill, I've heard people refer it to as, this is it's hollow. It's hollow inside. So I'm not going to hot rod this much. I'm probably going to keep it around 3 amps on high. But in order to conduct heat, you want to have good contact on the back of this this board here, this PC board, MCPCB board. So I'm going to do is I'm going to press a piece of aluminum into here just to give it full contact to give it better heat conductivity. Of course, I'll have to leave room for the board, the driver board down inside, and that brings up another problem. This isn't a common size driver board that I could find. So once I pull this out of here, I'm going to have to measure my new driver board, which is around 17 millimeters, and put this in the lathe and slightly open this pocket up to receive the new driver board. I'll probably like to leave it still a slight press fit just so it retains itself some. So since I'm not going to be saving this driver, at least I don't have any plans on saving it, I'm going to cut this off here. Just clip these wires. And if I ever want to reuse in the future, I can always resolder new wires, but it'll just go in the parts bin for now. So there you can see there's the LED out of there. It's kind of an old style LED. And here's the driver board. So this was originally made with a little boost driver on it to boost the AA voltage up to enough to run the LED. Since I was running it on a higher voltage lithium cell, it wouldn't run off AA's anymore, so it cooked something in this board. But it would still change modes. So I've got a package in the mail here, some parts that I bought. So this is the new LED. This is the new LED. You can see it's 4000K 90 plus color rendering index. It's on this copper board here. So that'll give me a lot better tint, and maybe even a little more lumens out of the light with a new driver. So as we can see, that fits fairly well in the top side there. So I don't think I have to modify. I don't think I have to be doing any modifications to this end of the pill. This is the driver that I selected. So this is a regulated driver. It's not a direct drive driver. The battery I've got right now is probably good to create 2.5 amps. I could put a unprotected battery in there probably, and this this driver is set up with regulators on it to run at just over 3 amps, which is about what that Nichia LED is rated for, so I won't be overdriving it at all. So I might have to pull that spring off there and just put a little contact nub for the positive terminal of the battery. We'll see if I have to modify that, but this is a Q light driver, so it's got various stars in here which you can short to the grounding ring to select different modes, but I'm going to leave it in the stock mode, which is just a low, medium, high, no flashing, no strobe modes. But this driver is quite a bit larger than the pill, so you see I'm going to have to do some machine shop work here. Open this up a little to get this to sit in here. So I measured it correctly. You should have enough material to leave a little rim left on this. But down inside here you see it's got a step in there, so if I want to put an insert in here to draw a little more heat away, of course it's not going to be the full thickness of this because I need to leave room on top of there, so the electronics on here have got clearance. So decide how I'm going to do that. So for the pill of this flashlight, this hole is it's about 466.5 thousandths in diameter, so just a little under ½ inch. Don't have any ½ inch aluminum around. Got some 5/8 here I can turn down. Shouldn't waste too much. So I'll turn that down, turn this down, and part it off to fit in here. Now that shelf in there isn't real thick, but I think it's thick enough to transfer some heat, so I'm just going to end up making a little wafer and pressing it in here. Give it a few thousandths press fit. I haven't decided if once I put it in there or I want to add some other means of fastening that disc in there other than just the press fit. I don't know if I'll maybe put a little epoxy in the back side here around the joint just to hold it, or even possibly get a couple of small screws and put it on the mating joint between the two pieces. I'll get this turned down, good for a good press fit on here, and we'll go from there. Yeah, I moved you around. You're sitting right on top of the phase converter now, so it's probably pretty loud, but at least you'll see what's going on. Give us plenty of room to part that off. decent. There's the insert for the pill. So over here on the arbor press. So I want to press this in flush with this face because this is where the LED board sits. I want it to make full contact on here to transfer heat well out of here. So I've got this piece of brass which just fits in here. So not only will that support this ledge that's being pressed on, so it won't tear out. It'll also let me press this insert in up to it and end up at the same depth. Let's press it in with this socket here. Real easy, and once it's started, drive it home. Okay, let's see if that's started. Looks like it went in there fairly well. Kicked up a little burr there. You see that that's now flush in there, so that'll allow the LED to sit flat on there and transfer some heat. That's fairly solid. I won't be able to push that back out of there by hand, but I still might consider putting some sort of maybe a little bit of epoxy down on the back here or something, or just to give it a little extra insurance that it won't come out. So now that I've plugged that hole in the center of this, I removed the passageway to route the wires. So in order to get this LED board back in there, I need to put a couple of holes down the sides to route the power wires for the LED. So it'll be partially in the side wall of the existing pill. So I'm going to use an end mill to poke these holes in here, so as it comes out the bottom side of the shelf that I pushed in, it'll be a nice clean straight hole, and it shouldn't wander like it would with the drill bit. So first thing I'm going to do, I'm going to use my edge finder here to find the center of this hole. Change this out for a 1/8 inch end mill. We'll drop these holes in and see what it looks like. So there, now you can see we've got 2 holes going through this, just going through the back there. You can see I did put some JB weld in the back of that just for some extra insurance to hold that piece in, but that'll give us plenty of room. I set this up in my 6-jaw chuck, and I was able to get it less than 2 thou run out, which I think is pretty good for what it is. I was afraid I was going to have to put the 4-jaw chuck on here, but I was able to get away with that. So I'd like this driver board to be a snug fit in here, so it kind of self-retains. It will sit on the tube of the flashlight below it. It is slightly larger than the inside diameter of the tube, but I'd like it to be a fairly snug fit in here, so I need to be around 658 thousandths instead of trying to get some bore gauge or something in there, which is very small anyways. I'm just going to cut it to fit the board. This is the board I want to fit. We'll put it in backwards like this just to test fit it. Test fit. We'll get it to be a nice snug fit down in there. See there's the 17 millimeter undercut for the driver. There's the holes coming through for our wires, and there's the aluminum piece that we pressed in there to make a solid bottom shelf for that to heat sink that LED. So I ended up putting it back into the lathe here because I found out what my problem was. Is these 7135 regulators run right out to the edge of the board, and I was hitting on those. That's why I couldn't quite get it in properly. So leaving the main bore at a 17 millimeter, I came back in here and put a second step just to clearance for these chips. While I was in there, I took my boring bar down the bottom and cleaned up some of the JB Weld down there too, so it looks pretty decent now. But you can see now that I cleared it out. It's a nice snug fit. Nice snug fit in there like it should be. And back on the workbench here, so you can see that driver is a pretty good fit inside this. So here's the holes and the where I put in there with the mill for the wires, along with the piece of aluminum that I pressed in there. So I'm going to go ahead and solder this LED board onto here, into here. I'll put a little bit of heat sink grease underneath it to promote the transfer of the heat from the LED board into the aluminum here. So there's it assembled. There's the board in here. I don't know if it'll focus on this. So this driver has got some stars on here, which you can short to this grounding ring to select different modes. But I want to use the default mode, so the tube on this is going to be so close to those stars, I put a little bit of Kapton tape over them just to make sure that they don't touch. Same thing on the LED board. I got that soldered in, and there is a little insulator ring that goes on top of this board, but I put some Kapton tape just on the positive side just to add some extra insurance that it doesn't short out. Now originally this had a centering ring in here to center the board, but this board fits pretty good in here, so I think I can get by. I think I can get by without a centering ring. So I'm going to put the original. I'm going to put the original insulating washer in there. So in the moment of truth, I dropped my 14500 battery in here. I did not charge this up, so this is the same level as we tested it last time. And the tail cap. So because there's a spring on the back of that driver, there is room in there, but just barely. So I took a few coils off the end of this tail cap spring just to give it some little bit of extra room in there. So we'll put this on. So I've not tried this out before, so now is a moment of truth. Well, it works. Low, medium, high. Low, medium, high. Seems to work pretty good. And let me, I'll get the lights off and get the camera set back up where we took the original shot. So this won't be a direct comparison because I don't know if my ambient light's the same. I didn't measure it. It's more of a visual thing. So there's low. Medium. And high. Alright. So it seems to be working pretty well. I charged the battery a bit up some. The color's a lot better. So all in all, it really doesn't look a whole lot different. The color rendition's a lot better. And my battery's a little low, but seems to be a little brighter anyways. This battery I got in here is only good for about 2 amps. The driver is good for 3. So I'll try a different battery in here. According to the data sheet, if I can get 3 amps out of this, I get about 800 lumens, which is pretty good for this little light. But it doesn't look a lot different than what it did before. But from my initial testing, the color rendering is a lot better too. So this will be a good for a pocket light. You know, I do inspections on machines and stuff. So I look forward to getting many more uses out of this. So hope you enjoyed this, and we'll see you again next time.